Okay, here we go. 2A.6 part 2, solving absolute value inequalities. So remember, inequalities means that I'm taking the equal sign out and I'm putting in my greater than, less than, equal to symbols, right? All right. So let's talk about our inequalities. So there are types of inequalities. The first one is when your absolute value is less than. So the first one is our less than inequality. Let me switch back to red. Okay. So less than, this is called our and inequality, is what we call it. If you ever take stats, it's going to be called an intersection situation. But this is our and situation. Okay. When we have this, we're going to be solving a joint inequality is what I call it. We're going to be joining it. Okay. So you're going to have a combined solution. When you're doing this, you also have to pay attention to whether it is just strictly less than or if it's less than or equal to, okay? Because we're going to be putting these on a number line. And when we're graphing them on a number line, we have to remember that if it's less than, it's an open circle, right? If it's less than or equal to, then it's going to be a closed circle. Does that ring any bells from middle school? Hopefully a little bit, okay? So if it's less than at that value, then it's a open. If it's less than or equal to, it's going to be a closed, okay? All right, the next one is our absolute value or inequality. Or just means that your absolute value is greater than, okay? It means that our absolute value is greater than. It also can be applied to when it's greater than or equal to, okay? We're going to pay attention to, again, whether it's greater than or equal to, because, again, greater than is open circle. Greater than or equal to is going to be a closed circle, okay? With greater than, I call this the split, okay? You're going to have that or, that split. You're going to have a split solution, okay? Are you cool? So with less than, we have a joint solution. With greater than, we're going to have a split solution, okay? So that means when we're looking at the graph, so when we're looking at a number line, if it's a joint solution, that means that they're being connected. Make sense? If it's a split solution, when we're looking at a graph, that means that they're going in separate directions. It's going to be literally split. And that's why I call them joint and split. All right. So let's talk about the steps to solve these. So the first thing, again, is always to isolate the absolute value. You want to always isolate the absolute value. I try to make sure that I'm isolating it on the left side so that I can read my inequality correctly. So you're going to decide which inequality do you have. Do you have an and situation? And remember, and is going to be our, which one again? It's our split, but is it less than or greater than? And is going to be our less than, remember? Okay. And is our less than, and or is our greater than. Our less than and our greater than. Got it? Then you're going to solve each inequality, and then you're going to graph the solutions on a number line. Okay. On the number line, you're either going to have a split or a joint solution. Okay, let's just do it. Yeah. All right, so up first, we have the absolute value of x minus 2 is less than or equal to 5. Okay, I gave you a hint that this is a and situation, right? Because it's a and situation, we're going to have a joint solution. All right, so the first thing we're going to do is make sure it is isolated. Is it isolated? Yes. Second, we're going to create our equation. So our equation for this one is that we get rid of the absolute value bars and it becomes x minus 2 is less than or equal to 5. And then this is the part that comes in, and it is greater than or equal to negative 5. And that's how you end up creating that joint. All right. And now you're just going to solve it from the inside. So whatever you need to do to get x by itself. So what do I need to do to get x by itself? I'm going to add 2. So what I do to the inside, I'm going to do to the right and to the left. 2 goes away. Now x is by itself. And what is 5 plus 2? 7. And negative 5 plus 2? Negative 3. So our answer is x is greater than or equal to negative 3, but less than or equal to 7. Did they not realize this? They left? All right, so this is our inequality. And if I got to write that as a number line. So on a number line, I'm going to have, here's my number line. I'm going to try to draw this to the best of my ability. Negative 1, negative 2, negative 3. We have 1, 2, 3, 4, 5, 6. I think I made it. 7. It's not 100% drawn to scale, but you get what I'm doing. All right. Because they are less than or equal to, at negative 3 and 7, it's going to be closed circles. And because it was an and statement, it's going to be joined. And that would be my number line solution. How we feel? Okay. So when we have that less than or equal to again, give me a moment to process. You're going to create a compound inequality, right? And all we're doing is the opposite on the left side. Okay. All right. So we saw an example of this one. Now we're going to see an example of or behaves more like our equations. Or is more like our equation. So again, step 1 is to isolate. Make sure your absolute value is isolated. Is our absolute value isolated? No. What do we need to do to isolate it? Divide by 2. Perfect. So now we have absolute value of x plus 3 is greater than 4. Okay. This one is going to behave like the equation, the or statement. That's because you're creating 2 separate ones. So it's going to end up splitting. So it's going to become feel. But you're going to have your original x plus 3 is greater than 4. And then you're going to have your opposite. So our new one comes into play. And that's going to be x plus 3 is less than negative 4. Do you see how they're opposites of each other? And this is why it's a or. And then you solve both to get x by itself. So to get x by itself on both sides, all I need to do is what? Subtract 3. So we're subtracting 3, and after we subtract 3, we're left with x is less than negative 7, or x is greater than 1. Is this canceled out? And then you combine. How do we feel? So this is your inequality solution. So on a number line, this is why it is split. So here's my number line. This time I'm going to draw a little more here. 0, 1. And I have negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. All right. Are the circles going to be open or closed? Open, because they're strictly greater than and less than, right? So they're going to be open circles at negative 7 and 1. And it's an or, so they are split. They are heading in opposite direction. How do you feel? Okay, time to practice it. So what we're going to do, Alina, you're going to have to go back with Unique, or Unique come to Alina, whoever. Each group is going to get a card, but we're going to all solve. So on page 73, we're doing 2A.6 class activity, okay? You'll all have one solution, okay? Your solution may not be the solution for the one on the board, but if you think your group has that solution, then you have to bring your answer to the board and show us your solution, okay? So each group is going to have a solution, but it may not be the one for the one that's on the board. Does that make sense? Okay, so I'm going to give everyone their group solution card. Actually, may not be you. They're playing who has it, and the goal is to correctly say I have it. All right. So up first, we have a fraction because fractions are our friends, and we tend to freak out with fractions, right? So it says 7 absolute value of x plus 2/3 divided by 15. Okay. For adding and subtracting fractions, I'm going to encourage you, if you're not strong doing it by yourself, to use the fraction feature on either Desmos or on your handheld calculator so that it gives you the reduced fraction value. Okay. All right. So we're on page 73. You're going to write down the problem and then you're going to solve it. Is this an and or statement? And because it is. Yes. So on here, what was the first thing you should have did? Divided the 7. So you divided the 7, which leaves you with the absolute value of x plus 2/3 is less than 15/7. Because remember, fractions are our friends. We don't try to change our friends, let them be them. All right. Now we know it's less than, so that's where it ends up creating that compound inequality, right? So you have less than, and then you're going to have less than, and then you're going to have greater than negative 15/7. Yeah. The goal is to get x by itself. So what did you do to get x by itself? You subtract 2/3 from everything, right? I'm going to squeeze it in there. Boom, there it is. Okay, what did you get after you subtracted 2/3? Anybody? Everybody? Somebody? What did I get on the right side? Okay. Guys, you did it in the calculator. Trust the calculator at least. All right, what did you get on the right side? I mean, the left side. Okay, these are improper, right? You all remember that term? Improper fractions. Okay, you may not have the improper fraction, but you may have the mixed fraction as your solution. Who has the one with the mixed fractions? You do, group one. You do. So when I said who has it, why didn't you say anything? Group one. Okay. To go from a mix to from an improper to a mix, remember all you're doing is dividing and then remainder. Y'all remember that guy? The dividing and the remainder? Yeah, I know. Fun times in pre-algebra and elementary. Okay. So if I was to do that, that's how I would get that. So 21 divides in 2, negative 59 2 times, right? With the remainder of the amount. Anyone takes a guess? 17 with a remainder of 17. So this can be written as negative 2, 17 over 21. 21 divides into 31 only one time with a remainder of 10. Okay. So bringing back some of those taught skills. These are both correct answers. You have to be able to read whichever format they give it to you in. I'm going to draw arrows, but does that make sense? Okay. So yes. Oh no, I got my answer is not there. Your answer is there. Okay. You have to be comfortable using your prior knowledge and going in between both. All right. Okay, next one. Absolute value of 2x plus 5 is greater than or equal to 15. Is this a and or an or statement? It's an or. So that means we're looking for a split solution, right? All right, go. All right, good job. I can count group 6. So you should have ended up with a split. Pew, pew. And that gives you 2x plus 5 is less than or equal to negative 15. And then you would have had 2x plus 5 is greater than or equal to 15 and solved from there. Yes? All right. Let's try another one, making sure we still got it. Is this a and or an or statement? Or, how do I know it's or? Greater than. Okay, try again. See if we can get a little faster. Continue. All right. Absolute value of 2x plus 9. Again, it's a split. So you have your 2x plus 9 is greater than 27, and then you would have your 2x plus 9 is less than negative 27, and proceed to solve. All right, our last one. Here we go. Absolute value of 4x plus 6 is less than or equal to 30. Is this an and or an or statement? It's an and statement. Okay, go. So the setup here is to get rid of that. You remove the absolute value bar. So you have 4x plus 6 is less than or equal to positive 30. And then you have 4x plus 6 is greater than or equal to negative 30. And your goal here is to get x by its self. So you use your inverse operations to get x by its self. Easy peasy. All right. How do we feel about part 2? Doable? And you are smart all along. You may not talk to me.